Hello student, welcome back to one more session of computer networking and security. In the previous session, we had solved some of the problems related to RSA. We will continue our session. So in this session, we will take one more problem. The problem statement is, so it's given P is equal to 5, then Q is equal to 11 and E is equal to 7 and capital P, that is nothing but 18. So this is lowercase p is 18. So it is given here P is equal to 5, Q is equal to 11, E is equal to 7 and capital P is 18, that is nothing but M is equal to 18. So we need to apply RSA algorithm. So as I explained in my earlier video, so first you need to find out N. N is nothing but P into Q, that is nothing but 5 into 11, that is 55. 55. Now you need to find out Euler tangent phi of n, that is nothing but p minus 1 into q minus 1. So the p minus 1 is 4 into q minus 1 is 10, that gives to 40. So we know E is equal to 7. Now E is equal to 7, that is public key is 7 or one of the key is 7. We need to find out D. So we need to find out D. So we have a formula D is equal to E minus 1 mod of pi n, that is DE is equal to 1 mod pi n, that is nothing but in our case it is 7D is equal to 1 mod pi n is equal to 40, 1 mod 40. So if I take 7D is equal to 161, then this will satisfy this equation 1 mod 40, that is 23 into 7 is 161, is nothing but 1 mod 40. It will satisfy this equation. So we got the value of D is equal to 23. So value of D is equal to 23. So now let me write here public key and private key. So first I will write public key. Public key is equal to KUN, that is nothing but 7 into n in our case is 55, and private key is KR and N. So now in our case it is nothing but D is 23 into 55. So now we got the value 7 and 23, that is E is equal to 7 and D is equal to 23. Now we will take the message is equal to 18. So we know to encrypt the text, you have to raise M4 to the power of E into mod n. So here the value of M is equal to 18 raised to the power 7 mod n is equal to 55 mod 55. So you can write this one, since this is a large number, you can write this one 18.4 into 18.3 mod 55. So you need to solve now. First you need to solve 18.4 mod 55. So let us find first 18 raised to the power 4 mod 55. So let me use the calculator here. So let me take 18 raised to the power 4 mod of 55, nothing but you will get 36. So you will get this value is equal to 36. So now you need to find 18 raised to the power 3 mod of 55. 18 raised to the power 3 mod of 55. So let me use the calculator once again. Raised to power 3 mod of 55. Nothing but you will get 2. So 36 into 2. Once again you need to take 50 mod of 55. 36 into 2 is nothing but 36 into 2 is 72 mod of 55. 72 mod of 55 is nothing but 17. The answer for this question as answer for C is 17. So now we need to decrypt it. So we got the value of C. To decrypt it, we got the value of C. C is equal to 17. So decryption process will give the plain text, that is M, that is nothing but C raised to power D mod of 55. So in our case it is mod of 55. So C is equal to 17. 17 raised to the power D. D is 23. So it's a very big number, mod of 55. So better you write 17 raised to the power 23 as 17 raised to the power 16. 17 raised to the power 4, 17 raised to the power 2. To 17 raised to the power 1 mod of 55. So first we need to find out 17 raised to the power 16, 17 raised to the power 4, 17 raised to the power 2 and 17 raised to the power 1. So let us first find out 17 raised to the power 2. So here when you calculate 17 raised to the power 2 mod of 55 gives you answer 14. So we need to calculate also 17 raised to the power 4 mod of 55. I can write 17 raised to the power 2 raised to the power 2 mod of 55. So here it is something like 70, since 70 raised to the power 2 is 14, I can write this one 40 raised to the power 2 mod of 55. So 40 raised to the power 2 mod of 55 gives answer 31. This gives answer 4046 mod of 55 and this gives answer 31. Now we need to calculate 17 raised to the power 8. So 17 raised to the power 8 mod of 55, that you can write like 17 raised to the power 4 raised to power 2 mod of 55. 17 raised to 4 is 31. 31 raised to power 2 mod of 55. This gives answer 26. Similarly, you need to calculate 17 raised to power 16. So let me write here. (17 raised to the power 16 mod of 55). I can write this one as 17 raised to power 8 raised to power 2 mod of 55. This is nothing but 26 raised to power 2 mod of 55. So 26 raised to power 2 mod of 55. So this gives answer 16. This is nothing but equal to 16. So here 17 raised to power 23 mod of 55 is nothing but I can write finally. So this is nothing but 16. 17 raised to power 4. 17 raised to power 4 is nothing but 31. 17 raised to power 2. 17 raised to power 2 is nothing but 14. And 17 raised to power 1 mod 55 is nothing but 17 itself, whole of mod 55. And when you multiply this one, you will finally get, after multiplication and simplification, you will get 18. That is nothing but our plain text. So students, will see now one more problem here. The problem statement is consider an RSA key set with P is equal to 11, Q is equal to 29, N is equal to 319 and E is equal to 3. What value of D should be used in the secret key? What is the encryption of the message M? So what is the encryption of the message M? So the value of M is equal to 100. So we have P is equal to 11, so Q is equal to 29. So what is the value of N? N is nothing but P into Q, 319, and Euler quotient is P minus 1 and Q minus 1, 280, and we know one of the key, that is public key, that is 3. Now you can apply the Euclid's algorithm method. By using Euclid's algorithm method, so you will get the value of, you can find out the value of D. So you can write 280 as 1 into 280 plus 0 into 3. Now you can write 3 is equal to 0 into 280 plus 1 into 3. Finally, to get value 1 into 280 in plus minus 93 into 3. So minus 93 into 3. So that gives the value of D. This is the Euclid's algorithm. So that gives the value of D is equal to minus 93 plus 280, that is 187. So we got D is equal to 187. Now the key is, secret key is 187 and 319. So we have here, let me take you to the blackboard. So we have the value M is equal to 100. M is equal to 100, and public key is equal to E into N, that is nothing but the value of E is in our case is 3, and value of N is equal to, the value of N is 319. Similarly, private key is D and N, that is the value of D in our case we got 187 and N is equal to 319. Now we need to find out the ciphertext. Ciphertext C is nothing but m raised to the power e mod n. So the value of m is 100, e is 3, mod 319. So you need to find out the value of 100, sorry, this value. So let us use the calculator here. So 100 raised to the power 3 mod 319, you will get the value 254. So this value is equal to 254. We got the value C is equal to 254. Now we have C is equal to 254. Now to get the message m is nothing but C raised to the power D mod of 319. So in our case C is equal to 254 raised to power D. D is nothing but so let me go to the previous page. D is nothing but 187. So D is nothing but 187. So this is a very big number. So to solve this number, I will use the other method. I will write this one as 254 10 into 254 10. So 254 raised to power 10, 254 raised to power 10, it continues 18 times. 254 raised to power 10 followed by 254 raised to power 7. So I can write this one 254 10 plus 10 plus 10 plus 10 plus 10 plus, so it is 18 times, total 18 times into 254 raised to power 7. So first you need to find out 254, that is you need to find out here 254 raised to power 10. So let's find out first 254 raised to power 10. So when you find out 254 raised to the power 10 mod 319, you will get answer that is equal to 111. So 111. So I can write 254 raised to power 10 is equal to 111. So I can write this one as 111 raised to the power 18 into 254 raised to power 7 mod 319. Further simplifying this one, I will write 111 raised to power 9, 111 raised to power 9 into 254 raised to power 7 mod 319. So when you solve 111, that is 111 raised to power 9 with mod 319, you will get the answer 199. So I can write this one is this equation as 199 into 199, and when you solve 254 raised to the power 7 mod 319, you will get the answer 144. Finally, you need to find out the mod of this product. So let's use the calculator once again. So 199 into 199 into 144, mod of this 319, this gives 100. So here this gives 100, which is nothing but our plain text M. So this way we can solve RSA related problems. Thank you for your cooperation. Thank you.